हरि करना।
So I'm gonna take up your more time. Just bear with me for a few minutes because so now I'm gonna explain the applications of the conditional probability in various machine learning models where all we use. So obviously, just learning a probability is not enough for a data scientist. As a data scientist, you should know which all machine learning models use this conditional probability, whether they use it or not. First, you should know that. If you, after knowing that, you should know where we use it and in what all applications we use it. So that's what I'm going to tell you now. So machine learning models that use conditional probability. So the first one, conditional random fields, CRF. Conditional random fields, these are discriminative models that model the conditional probability of a sequence of labels given the input sequence. So conditional random fields models, CRFs are discriminative models that model the conditional probability of a sequence of labels given the input sequence. I hope you're getting my point. What I'm trying to explain repeatedly, I'm trying to tell probability of B given that A, conditional probability of a sequence labels given that input sequence. I hope you got my point at least now. Okay, next let's take one example from CRF. So conditional random fields, CRFs, are a probabilistic model used for structured prediction, particularly in natural language processing, NLP, and computer vision in both cases. So this is very important for computer vision as well as NLP, that is conditional random fields are a probabilistic model used for structured prediction, particularly in natural language processing and computer vision. So they are used to label sequences of observations such as parts of speech in a sentence or image segmentation. Okay, so this is very important. Conditional random fields, so these are used to label the sequences of observations such as parts of a speech in a sentence or image segmentation. So CRFs can be trained using maximum likelihood estimation and incorporate conditional probability to model dependencies between observations. So let's see some of the example use cases for this. So named entity recognition, we call it NER, named entity recognition in natural language processing one. And the task of NER, that's a named entity recognition, is to identify and classify named entities such as names of people, organizations, and locations in text. So CRFs can be used to model the dependencies between the words in a sentence and predict the most likely labels for each word. Okay, and the second one we have is Gaussian mixture of models. Gaussian mixture models. So in Gaussian mixture models, these are generative models that model the joint probability of the input features and class labels and use conditional probability to estimate the likelihood of a given input belonging to a particular class. So they use these Gaussian mixture models use conditional probability to estimate the likelihood of a given input belonging to a particular class. Let's take one example and test use case. So Gaussian mixer models, we call it as GMMs. GMMs. So GMMs are a type of probabilistic model used for clustering and density estimation. They model the probability distribution of a data. They model the probability distribution of data as a mixture of Gaussian distributions, each with its own mean and covariance matrix. So example use case for this is anomaly detection in finance. GMMs are a type of probabilistic model used for clustering and density estimation. They model the probability distribution of data as a mixture of Gaussian distributions, so each with its own mean and uh, covariance matrix. So let's see some of the examples. Example use case. So anomaly detection in finance and GMMs can be used to model the normal behavior of financial transactions, and any transaction that deviates significantly from this model can be flagged as potential anomalies. So these Gaussian mixture models are widely used for the anomaly detection. Okay. So next one that we have here is expectation maximization algorithm. What is that? Expectation maximization algorithm. This is an iterative algorithm. It's an iterative algorithm used to estimate the parameters of models that involve latent variables such as Gaussian mixture models using conditional probability. Okay, so now let's see one example for that or the use case. So the expectation maximization algorithm is a method for estimating the parameters of probabilistic models when some of the data is missing or incomplete. It iteratively calculates the expected value of the missing data and maximum likelihood estimate of the model parameters. So example use case for this is image segmentation in computer vision. Very, very important. Very, very important. Segmentation in computer vision, and EM can be used. That is expectation maximization algorithm can be used to segment images into regions based on the underlying probability distribution of the pixel values. So in this case, the missing data are the labels for each pixel, and the EM algorithm can estimate the most likely labels based on the observed pixel values. Then reinforcement learning, the most important one, reinforcement learning. In this type of learning, an agent learns to take actions in an environment based on the conditional probability of receiving a reward given the current state and action. I'm repeating this again. Reinforcement learning. So in this type of learning, an agent learns to take actions in an environment based on the conditional probability of receiving a reward given that current state and action. So in reinforcement learning, it's obviously a type of machine learning used for decision making in dynamic environments. So reinforcement learning agents learn to take actions that maximize reward signal based on the state of the environment and actions taken in the past. So example use case is gaming, game playing. So Reinforcement learning can be used to train agents to play games such as chess or Go by learning from the rewards and punishments received during a gameplay. So, in this case, conditional probability is used to calculate the probability of a particular state of the game given the previous moves and the current state. So, in this case, the game playing case, conditional probability is used to calculate the probability of a particular state of the game given the previous moves and the current state. Previous moves and the current state. Probability of B, vertical bar, and then A. That's how we are using here.